So this is the step-by-step tutorial for how to build the automated blinds powered by Neo. Starting here with our hardware, we have a Raspberry Pi Zero running Neo on it. On top of that, I've soldered the GPIO pin headers that can allow us to attach to the GPIO pins. Over here we have the Adafruit PWM servo motor hat. This allows us to control servo motors through these pins. One of them is connected here. And finally, we have the Adafruit UV sensor that is attached to the motor hat through all the I2C pins, plus power and ground. So, back into the software, we're going to start with a fresh terminal inside of that Raspberry Pi, and into it we're going to clone our Neo project template. So, git clone that project template, and then I'm going to call this instance automated blinds. That'll clone in. So now if we go into the automated blinds, we need to set up our Neo instance to communicate with its pubkeeper server. So if we open up Neo env, we are going to set the pubkeeper client variables and WebSocket brew variables. That requires us to jump over to the designer, and we're going to create a system. I'm going to call it automated house, because eventually I want to automate everything in my home. Once that's created, we can open up the edit menu and copy in all the variables we need. So pubkeeper host, we'll go right here to pk host. If you follow along in the docs, we're also going to clone that or copy that into WebSocket host and change pubkeeper to WebSocket. Next, we're going to take our port numbers, which is just 443, clone that into PK port and WebSocket port. Finally, the PK token, which we will clone right here. Save that. Now we want to add our blocks into the project. So we go into blocks. Here there's a lot that are already created there for us, but we want to add a few more, starting with our state block. So we're going to git submodule add that block. Actually, that already exists. I missed that. No worries. Conditional modifier. That'll clone in. So now we see the conditional modifier block. And the last two are going to be custom blocks that I've created for this project. Super easy. We just took example code from an open source project, and I added the block wrapper around it so that it can create itself, and then it creates signals with all of the data we want for UV sensor. So I'll add that guy in. Not clone. So module add. And the last block we want is this other custom block for the servo hat. Same thing here, it's really small. Create the device, set a frequency, and then I just move the servo to whatever length we set inside of the configuration. So get that into there. So now we have all of our blocks installed. One thing I want to do before I run anything is do git submodule update init. And this will take all of our default blocks that already exist in this repo, but actually clone the block data into them. All right, that's all there. So we'll jump back to the root directory of our project directory, and we're ready to run this Neo instance. We'll do Neo run. We'll let that start up. All right, Neo's running. So open up our automated house system, and I want to add that instance into the system. So I'm going to call it automated blinds. Host name is going to be the IP of this Pi, which I'll add in now. And by default, new projects run on port 8181. So that'll open up, and now we're connected. First thing we'll do is add our first service, which is going to read UV data from the UV sensor. So read UV data. Want to add in a simulator to drive this. I always use the identity interval simulator. We'll just call it driver. And I don't need to get UV data that much, so I'll just give it every 30 seconds, grab data. One signal each. -1 tells it to grab signals indefinitely. Once that's in, next thing I want to do is add an instance of the Adafruit SI1145. Call this read UV. This block doesn't have any special setup, so I can just save it. And we'll connect it to our simulator. Last thing I want to do is publish this data. Inside of the publisher, I'm going to give it a topic. I'm going to give it the service name, followed by block name. Not necessary, but that's what I like to call it. We'll save that. And then we're going to create our next service. So this service only does one thing with 3 blocks, grabs UV data and publishes it out. The second one's going to take that data and it's going to move the servo. So I'll call it move servo. First thing this needs to do is subscribe to that data. So I'm going to call this subscribe or sub UV. Topic is going to be the same thing I set for the past one, so read UV data .pub UV. And now that those topics match, we can see that we have this filled in. This tells us it's going to be getting data from the read UV data service. That's good. That is going to go into our conditional modifier. I want to take that UV data and determine how bright it is. So set the brightness. Too bright, I'll open the blinds. Not bright enough, I'll close them. Inside of that, we'll exclude existing. We'll call it blinds if we want them open. The formula is going to take UV index from that first service. If it's greater than 0.1, I want to set it to open. Otherwise, close them. So now every signal that comes through will determine if the blinds need to be open or closed. And I want to pass that into a state change. This is an important block for working with hardware. This is going to be I only want to check when the blinds change. So I'll exclude existing. It doesn't need a group. The initial state will say the blinds will be closed. And the state will be blinds from our previous block. So walking through our service, take UV data, check how bright it is, set the blinds to be open or closed, only log that change once between going from closed to open or open to close. And that data needs to go through a filter. And this is going to be determine which way we rotate. So rotate blinds. And my filter condition, I'm gonna check the blinds set to open. Although this is a state change, so blinds go to state. So here, open or closed, a state will be made with that variable, and if that state is open, I'm gonna rotate to open. So add in the servo block. This one will rotate open. Frequency and channel need to be at 0. Pulse length I found for the blinds here at 250 are good to open. So we'll save that block and connect it. We'll add in our servo control to close it. So rotate to close. Same thing here, servo's on channel 0, pulse length I found to be 480. We'll rotate it to the closed position. So we'll connect those. Save that service, start it. We'll do the same thing with the UV data. We're going to start it. So once these services are both started, we can go over to our blind setup, and our UV sensor is constantly taking in UV light. Right now it's not quite bright enough to rotate them because there's no sunlight in here, but if we simulate enough, it'll rotate our blinds open. If we take that away, the threshold should drop and it'll close. All right, so the next step will be to take this system and we'll move it towards the blinds and hook it up. So here is another motor I've already set up. It's a little bit bigger and more powerful. It's in the build list. Onto that, I've taped this handmade stick that kind of extends the arm, so when it rotates, it actually can move enough to pull it down. I will plug this motor into channel 0 where this original motor was. And then I'll take the UV sensor and set it up so that it can see some light.